Video number 145, angle measures of a triangle. The first theorem would be that three interior angles of any triangle, angle 1, angle 2, and angle 3, if we were to add these angles together, measure of angle 1 plus measure of angle 2 plus measure of angle 3 will equal 180 degrees for all triangles. The reason this works is because if you were to cut these angles out, they would form a straight line if you were to take these three. So this would be angle 1 over here perhaps. Here's angle 2 right here, and then this would fit angle 1, angle 2, and angle 3, and you would have a straight line which would be half of a full circle. So that's why this theorem works out. So, nonetheless, in this particular figure, what we have here is we need to get these two interior values. Now we know vertical angles are congruent from basic geometry. These two angles here that form an X are congruent. And then these two angles here are a linear pair or supplementary angles here. So these two, so you just subtract from 180 and you'll get the 53 here. Then X, 57 and 53 gives you a total of 180. You get 110 here, subtract the 110, you get 70 degrees for X. Alright, that's how that works. Next one. What happens when you have a right triangle? Well, if all triangles sum is 180 between all three angles, what does that mean about the two acute angles of a right triangle? Well, you already have 90 degrees here. Therefore, the two acute angles have to have a sum of 90. Because you're going to have 90 degrees here, 90 degrees there between those two. So we come up with our own little theorem here just by analyzing the situation. So we can say that these two angles here have to have a sum of 90 degrees because all three of them are 180. You already have 90 that's spoken for right here. So therefore 90 is the sum of those two angles. Add the algebraic expressions together. 5x is 75, x is 15. Therefore the angle measures are 60 and, well actually that would be 30 degrees. Alright, because the 15 would plug into there. 15 plug into here. 4 times 15, 60. 15 plus 15 is 30. Alright. Next one. Here is a diagram. Now this is going to discuss, we're going to discuss angle D. Angle D is going to be referred to as what's called an exterior angle. Now an exterior angle, the definition, the basic definition, is that it is an adjacent angle that is also supplementary to one of the interior angles. So this angle here, angle D, would be called an exterior angle. Alright, now let's take a look at a basic pattern. Does everybody agree that A plus B plus C is 180? And A plus D is 180. You see that? Because you have a straight line here, so you have half of a full circle, right? Well, guess what? What do we know about B and C? B plus C has to add up to something to add to A to make 180. Well, doesn't D serve the same purpose? D added to A is 180. B plus C added to A is 180. Therefore, logically, B plus C equals D. This is referred to as what's called the exterior angles theorem. The exterior angles theorem. B and C would be referred to as what are called the remote interior angles. Okay? So these two remote interior angles will add up to D. Now this pattern continues. What if we were to go over here and call this angle E? We could say that angle E equals the sum of, drum roll, bam, B and A. Okay? That's how that works out. Let's take a look and apply this situation. We then are asked to solve for X and Y. Well, what do we know using the exterior angles theorem? We know that 9x equals 5x minus 10 plus the 55. Bam, there it is. Subtract 5x, combine together, divide by 4. X is 11.25. Solve for y. Plug in 11.25 here. You get 99 plus the 225, so 101.25. Subtract that on both sides. 78.75. Questions or concerns, send me an email, and of course, good times.